thank you for joining me. My name is Grigory. I'm a head of developer relations and a Python developer at Singular team. We do mostly out stuff. We hire developers, teach them, and contract them out to our clients. And our clients, they are different businesses, small businesses, medium businesses, big businesses. And they have what is called business need. And within such a business need for software development, there are biases about the best technology. They think that if they need some backend development, it's PHP or maybe C# or Java. And for ML, they prefer Python. They prefer front-end for JavaScript development and Ruby for full-stack development. But if we look at top 50 Y Combinator startups, the picture is different. Most of successful startup companies, they use Python and Ruby. These languages are different, but they have one thing in common. They referred as slow languages. And that's my topic for today, why Python is slow. And I want to unfold this topic starting with how a modern CPU works. The electric impulse travels through CPU cores, and these cores, they try to execute as many instructions as possible, a few billion times per second. And as many as possible is a key term, which means CPU speed is how many instructions it can perform per some interval of time. And each core, it tries to perform as much instructions as possible. It reads instructions from memory, and instructions, they are mostly simple. They are math, branching, memory access, and this memory, it's cached between registers and physical memory. And the difference in access time is more than 100 times. That means the speed of our code is how it handles memory. And memory is handled differently by different programming languages. It can be handled manually, like in C++ or Rust, where we developers allocate memory, access memory, deallocate it. Or we can use garbage collector and compile our language based on types like in C# or Java. Also, we can avoid using types but still use garbage collector by compiling a very simple language like a JavaScript or Lua. There is one more alternative. We can use virtual machine that will handle garbage collector and no compilation is required. Such approach is used by Python, Ruby, PHP, and many languages. Virtual machines, instead of compilation, they handle memory, allocation, deallocation, access. They handle object types at runtime, and they provide rich language semantic. For example, with the Python programming language, we can easily change how negation works for our type, and all our code works completely different now. Virtual machines are known to be slow. And let's see, Python. It handles memory, it handles object types, it provides a rich language semantic, and it uses a virtual machine for all these tasks, which is slow. But wait, not all languages that use virtual machines are slow. For example, JavaScript programming language, it handles memory. We do not need to allocate or deallocate memory in JavaScript and in Python. It handles object types. We do not need to specify any types within our source code. It provides a rich language semantics. Ask any JavaScript developer, is the language good? And they will answer, yes, it's an amazing programming language. It uses a virtual machine for all of these tasks, and it is very fast, comparable in speed to C++. One of the points is a lie. Actually, it's about richness of JavaScript semantic. It is not a semantically rich language. And the secret of JavaScript speed lies within its V8 virtual machine with just-in-time compilation. This simple semantic allows Sun Hotspot JVM team to create a really fast virtual machine. And this team, it was led by Lars Bach, who basically create virtual machines for his entire career for 25 years. He is the world leading expert at creating virtual machines. He made them in Sun and now in Google. So this virtual machine is an expensive one-time miracle created by a top team of software developers. And now they have issues because JavaScript language, it evolves, and within which this evolution offers, we want richer semantics, and V8 development team, they like, oh, if we add this to the language, that will slow things down. We cannot add it. Please help us, anybody. That's the issue with just-in-time compilation. But 100 times slower. What if we add just-in-time to Python? There are such projects available. And just for reference, if we take some synthetic test, which C++ handles within 20 seconds. The normal implementation of Python took more than 3 seconds for such task, which is more than 100 times slower. By the way, same numbers are with Ruby. But if we enable JIT, just in time, using PyPy, for example, it will become 10 times faster, not 100 times, but 10 times. And again, comparable times are with Ruby. These tests are synthetic. And for big projects like number crunching, machine learning, big code bases with hundreds of thousands lines of code, enabling just-in-time compilation is not a silver bullet, and our code, it can be faster, like 2 times, 3 times, but not 10 times, with compatibility issues. So most Python developers prefer not to enable just-in-time compilation and live with a language which is 100 times slower than C++ because of its rich syntax and semantic. How do we live with such a slow language? First of all, native extension. GIL, Global Interpreter Log, that is used by garbage collector to provide a rich semantic. It limits on how our Python code can execute with threads, how it can scale. But with native extensions, they are written in C++. They raise global interpreter log, and they can work simultaneously, processing numbers, images, data, audio, video. There are thousands of libraries written in C++ that can concurrently handle CPU intensive tasks. This is the main way for the Python developers to cope with the language being slow. The language itself, it acts as a high-level glue that glues together different native libraries, different high-level primitives, and for example, by writing some API with fast API framework with some JSON handling libraries, most of the code being executed, it will be a very fast C, C++, and Rust code of these libraries. And our Python code, it will only provide high-level instructions on what to do. And with modern Python, with native extension, it scales pretty well with processes and threads within a few servers. We can achieve hundreds of thousands requests per second. Servers are cheap and developers are expensive nowadays. Also, async await development is on the rise, which allows to use non-blocking Python code where we access some network resources, and Fast API can handle hundreds of thousands concurrent connections within one server, which is an impressive number. What are natural targets for our language glue? First of all, machine learning and data science. They are natural targets for Python due to its history. 30 years ago, Python was created as a language to be used as a high-level glue, and it settled within academia. And through the years, it was promoted by scientists, making each new generation of scientists to use Python more and more for their everyday tasks, because it's a nice high-level glue. It's compatible with existing native code. It can call existing native code, use native extensions. So after the development of more and more elaborate machine learning and data science solution, obviously they were developed in Python, and now Python is the default language for such tasks. Also, it's a default language for tests, for automating testing, for browser manipulation, for any kinds of automation. That rich semantics and easy syntax that I previously mentioned allows new developers on board to Python very, very fast. So it's an ideal language to teach people how to develop software, and they can use this knowledge to do automated tests. Also, all backend development with non-custom number crunching is great with Python due to support of libraries, abundance of them, and native extensions which are readily available for us. What does the future holds for our beloved language. First of all, lots of research is being made right now regarding the language speed. For the sake of machine learning, we are fighting with global interpreter lock, so many Python threads can concurrently access gigabytes of data stored in memory in one process, and there are two projects to tackle that. First of all, it's the GIL removal project, which will be available in a few years. It's a work in progress right now. And secondly, it's the Python sub-interpreters, which will land at the end of this year in version 3.12. By the way, Ruby already had interpreters a few years ago, and that project was not successful because sub-interpreters means that many threads within one process have each own virtual machine, and then they can access read-only shared data, but they cannot access that shared data for writing by default and need special API for that. This means that all libraries that share data between threads is incompatible with sub-interpreters by default. Also, the implementation of sub-interpreters in Ruby, it had the same global interpreter lock for all threads. And garbage collection, memory management, it kills performance gains very, very fast. I don't know how sub-interpreters will be implemented in Python 3.12, and we will learn it at the end of the year. And what I want to discuss after this talk. First of all, is it even viable to create such languages with rich semantics that are slow? Maybe we need to focus on languages that are not so rich, not so easy to use, but extremely fast. For example, Rust programming language. And what about prices for computation, comparing them to salary of us software developers? Maybe servers are not so cheap nowadays. Second, I want to discuss this take on rich semantics that Python uses with the focus on really simple syntax available for new software developers. That is not the only way, and for example, in Ruby, it's also a very semantically rich language, but the syntax, it's complex, it's hard, it's not for new developers, but for experienced developers. Such syntax allows to write less code faster and with more meaning. What about monolith and microservices? Right now I can see that companies, teams are moving back from microservices to monolith because we already know how to separate concerns in our big source code bases, which does not require microservices separations. I also want to elaborate about languages like C# and Java, which also uses garbage collection, but instead of Python, they use compilation instead of virtual machines, and for that reason, they cannot add rich semantics and be as good as Python for everyday use. Or can way. With Python, we also have types, but they are optional, gradual types that allows us to set specific traps only in parts of our source code which are important for us. How viable is this approach? I can see some teams misuse, overuse, and abuse types, writing more type-related code than business code in Python. These and more topics are for us to discuss right now. Thank you.